Hello, this is Nicholas again. I am making part 2 of the questions that we did not get to in the pre-calc class, not class, I guess it's coaching. So this first one here is for what value of I is equal to cotangent x plus tangent squared x all over sine x an identity. Okay, so what am I gonna do? You know, whenever in doubt, just convert everything to sines and cosines, right? So our whole idea is we want to simplify this, okay? And really the annoying thing is that you have to simplify it the way mu alpha theta simplified it, because it's a multiple choice test, it's not a proof test. So you kind of have to examine their answers and you know, maybe I should write the answers down. Kind of examine their answers and kind of massage what you're doing so that it looks like their answers. So their first answer is A cosine x plus sine x all over sine x cosine x quantity squared. The second one was just sine x plus cosine x. The third was a bit longer. Secant x cotangent squared x plus cosecant x tangent squared x. Fourth one was secant x cosecant x squared x. Secant squared x cosecant squared x minus secant x cosecant x, and then the last one is always no to none of the above. Okay, now we got that down. So I'm going to convert everything in what I've circled here into sines and cosines. So we're going to get cosine x over sine x plus sine squared x over cosine squared x all over sine x. Sine x is what you use when you have a stuffy head or a stuffy nose. Anyways, so now I'm going to make this numerator here into the lowest common denominator of, so I'm going to get cosine cubed x plus sine cubed x over sine x cosine squared x times 1 over sine of x, because we were dividing by sine of x over 1, which is the same thing as multiplying by the reciprocal. So we're going to get cosine cubed x plus sine cubed x over cosine squared x sine squared x. And if you weren't paying attention to your cubes, you might select A, but we are paying attention to our cubes, so we're not going to select A. Anyways, now this top part can be factored using the sum of cubes. And I guess if you don't remember, I probably should write it down for y'all. A cubed plus B cubed is equal to A plus B times A squared minus AB plus B squared. And if you don't believe me or whatever, just FOIL this out and you're gonna, if you do it right, you're gonna get that. So let's simplify this. We're gonna get cosine x plus sine x times cosine squared x minus cosine x sine x plus sine squared x. This doesn't really look very simplified, does it? Over cosine squared x sine squared x. Now, this and this, when added together, give 1, which was really the whole point of why we did this. So we're going to get cosine x plus sine x times 1 minus cosine x sine x all over cosine squared x sine squared x. Now I'm going to FOIL the numerator. We're going to get cosine x minus cosine squared x sine x. Still can't get over that sine x pun I made. Anyways, plus sine x minus cosine x sine squared x all over cosine squared x sine squared x. Now, this is a monomial divisor, and whenever you see a monomial divisor, it's a good idea to split that fraction up into its constituents. In other words, the things that make it up. So, in other words, divide each term in the numerator by your monomial or one-term denominator. So when we do that, we're going to get 1 over cosine x sine squared x minus sine x over sine squared x plus 1 over sine, that's a horrible sign, sine x cosine squared x, that's a sine x right there, minus cosine x over cosine squared x. Now we do some simplifying here. The first fraction that I've written down becomes secant x cosecant squared x. The next one, now realize this one sine of x cancels with that one sine of x, leaving just 1 over sine of x, which is cosecant of x. Now the next one becomes plus cosecant x secant squared x minus, and again that one factor of cosine x cancels with one of those, leaving just 1 over cosine of x, which is secant of x. Now I'm going to rearrange these terms a little bit because you see how they all have secants and cosecants, so I want to rearrange them so that I can pull out some common factors and maybe use some Pythagorean identities. So, what am I going to do? I'm going to make it secant x cosecant squared x minus secant x, which is that last term here, plus cosecant x secant squared x minus cosecant x. Those were these two middle terms here. Now, from these first two terms here, you can pull out a common factor of secant x. And hopefully you're saying, wait a secant, I see the answer. Times cosecant squared x minus 1 plus, now in the second two terms I can pull out a factor of cosecant x times secant squared x minus 1. Now I can simplify this sum. I'm going to get secant x. Now I know 1 plus cotangent squared x is cosecant squared x. So I subtract 1 from both sides. I should write it down, I guess. 1 plus cotangent squared x is equal to cosecant squared x. So I'm going to subtract a 1. It's going to go away when we're left with cotangent squared x. Now cosecant x times, and secant squared x minus 1 is tangent squared x. And what is that? That is c. So I see the answer. Anyways, hopefully that made sense to you all. I have one more I wanted to do that we didn't get to. I don't want to save this. Now the next one was, this is a messy one, simplify sine 12x plus sine 2x over cosine 12x minus cosine 2x. So, now I know you guys know that we have an identity for sine of 2x and cosine of 2x, but you're thinking sine of 12x, well, it turns out there is an identity for it, or there is a way to get an identity for it. And if you're interested, you use what's called a de Moivre's theorem in the Argand field, but we're not going to do that. So what we're going to do is whenever you see a problem like this where you've got kind of like big like coefficients in front of your angles like 12x or 14x or 7x or 5x, we're going to be using two various types of formulas. We're going to be using sum to product formulas and product to sum formulas. And so the idea is that here you have the sum, you have the sum of two trig functions with different angles. We want to combine them into a product. And so hopefully that product, when we combine the numerator and the denominator into a product, maybe some factors will cancel out and we'll get something nice, which is usually the case. Otherwise I wouldn't be giving you this question. Now, we'll be using the product to sum formulas, which you'll see, but just realize that these two, that they're there, they exist, and know that when you're kind of dealing with this type of question, this is what you're going to be going to use. Now, these formulas are very messy, and I don't know them off the top of my head myself because they're literally only used in mu alpha theta type questions like this. But I will show you, because I don't know them off the top of my head, so I'm going to have to derive them myself, but I will show you how to derive them, and on the actual competition, I'm going to go through the steps, but on the actual competition, it's not going to take you very long to derive these on the spot if there is even a question like this. So, in other words, deriving them on the spot rather than memorizing, I think, is the safer way to go because, you might mix up a plus or a minus sign because they look all so similar. So, how are we going to start with this derivation of the product to sum and sum to product formulas? We're going to start with the following. We know that we have sine of a plus b being sine a cosine b plus cosine a sine b. And we know sine of a minus b is equal to sine a cosine b minus cosine a sine b. In other words, the same thing, just with a minus sign in the middle. Now, since we're adding in the numerator of this equation here, as I've circled, I'm going to add these two together. I'm going to get sine of a plus b plus sine of a minus b is equal to, now those are going to cancel because it's plus and then minus and it's the same terms, so we're just going to get 2 sine a sine b. And this is the product, so you start with a product and you go to a sum. Okay, so that's the product to sum formula for the addition of two, or for the multiplication of two sines of different angles. And we're going to use this formula to get to the sum to product formula. So we got the products to sum formula. We're going to use that to get to the sum to product formulas. And I'll go over this all again so it makes sense. Now we have two cosines here, so I'm going to list the angle addition formulas for those as well. We know cosine of a minus b is equal to cosine a cosine b plus sine a sine b. And we know cosine of a plus b is equal to cosine a cosine b minus sine a sine b. And since I am subtracting here, I'm going to subtract these two equations here. So I'm going to get cosine of a minus b minus cosine of a plus b is equal to, now since I'm subtracting, these are going to go away since they're the same, and I'm going to get what am I going to get? Cosine of a plus b. Okay. That's minus a negative, so I'm going to get 2 sine a sine b. I'm gonna just for consistency's sake, since I started with the addition of two angles, sine of a plus b, and I did started with subtraction here, I started with addition. I'm gonna make my formulas consistent. In other words, what I'm gonna do in this formula is I'm gonna multiply it by a -1. So what that's going to do basically is just flip all the signs. So I'm going to get cosine of a plus b, right, because that negative, this negative becomes a positive now, and then this positive here becomes a negative. So cosine of a plus b minus cosine of a minus b is equal to -2 sine a sine b. And that is looks a lot more consistent now, see, because I have sine of a plus b, sine of a minus b, cosine of a plus b, cosine of a minus b. I just wanted it to be consistent for you all. Now, I don't really like the sum of these two angles, you know how I have a plus b and a minus b as my input for sine and cosine, right? Here I want to get it to look like this. Here I just have, you know, I don't have the sum of two different angles here. I just have 12x, you know. So I'm gonna let a plus b be equal to some other angle c, because I just want it to be one angle. I don't want it to be the sum of two angles. Similarly, I'm gonna let a minus b be equal to d. The difference of two angles being just one other angle, call it d. Now, from this formula and this formula here and here, I'm going to use that. Now, so I know sine, now a plus b, we let it be c. So sine c plus sine d, because we define d as a minus b, is equal to 2. Okay, now I know what I'm going to do is I'm going to add and subtract these two equations. I'm going to add these two equations together first. I'm going to get 2a, plus b and minus b are going to cancel. 2a is equal to c plus d. A is equal to c minus d over 2. And I guess I'll write them again. A plus b is equal to c. A minus b is equal to d. If I subtract these two, the a's are going to go away. I'm going to have b minus a negative b, which is 2b. Is equal to c minus d, so b is equal to c minus d over 2. So 2 sine, and now a is c minus d over 2 times sine of b, which is, oh shoot, sorry, a is c, I don't know why I changed it to a minus sign there. A is c plus d over 2. I'm sorry, that probably confused you a little bit. A is c plus d over 2. B is c minus d over 2. And this is why at the beginning I said it would be very hard to memorize all these, because they just look so similar with all the, but you're just kind of fiddling with the plus and minus signs, and so it's very hard to memorize them. I never could memorize them. So, and again, b is c minus d over 2, so I'm just plugging that in there. And this formula right here is what we're going to use on the numerator here. See, we're starting with a sum, and we're making it into a product. Now, for my other formula, this one here, I'm going to do the same thing. Cosine of, and now we defined a plus b to be c, plus, minus, see, the signs always mess you up. Okay, cosine a plus b minus cosine of a minus b, which we defined to be d, is equal to -2 sine c plus d over 2 sine C minus D over 2. And this formula is what we're going to use for that denominator. And I mean, just look at how similar those look. They're just so similar. I mean, if you can memorize those, you know, all the power to you, but I just was never able to memorize them. You know, if you know this derivation and you can kind of go through it real quickly in your head, I don't see why it's all that bad. In fact, I think it's really better, you know. Proof is math. I mean, the art of math is proof, but okay, I don't want to, you know, get like philosophical on you. Now, using these two formulas here, I'm going to simplify what I have written up here. So sine of 12x plus sine of 2x becomes, by this first formula I've written you know, down here, we're going to get 2 sine of, now our c is 12x, our d is 2x, so we're going to get sine of 12x plus 2x over 2 sine 12x minus 2x over 2 over negative 2 sine of 12x plus 2x over 2. Wait. Have I? That's funny. Oh man. At the very beginning. Okay. I knew right from the, okay. Slight mistake. I'm sorry. This should be cosine. Okay. Right here, when I added them, I had sine A cosine B plus sine A cosine B, and I made it 2 sine A sine B. Should have been 2 sine A cosine B. Cosine B. Oh, what a ding dong. So this should have been cosine. Okay. Did I do this one right? Sorry. Sine A. Yeah, that one's right. It was the first one. I'm sorry. Yeah, don't make a dumb mistake like that on the test. Because I was like, you know, I looked at it and I was like, well, I'm just gonna end up getting the same thing on my numerator and denominator, and I know for a fact that this is not always 1. So I realized I messed up somewhere. Okay, now by my second formula that I've written here, which I know is right now, I'm gonna get sine of 12x, and that should have been an x there, 12x minus 2x over 2. Now, this simplifies into 2 sine of 5x cosine of, oh my gosh, I'm making so many mistakes. 2 sine 7x, 12x plus 2x is 14x, divided by 2 is 7x, cosine of 5x. It's getting ahead of myself. Over negative 2 sine 7x sine 5x. And now this is the whole point why we did this, is because look at this. Those go away. So those products, those factors canceled out, leaving us with just, and this negative, there's a negative sign out here because of here. We get negative cosine 5x over sine 5x, which is negative cotangent of 5x. And that is what this simplifies to. Wow, that was a very messy problem, and that actually turned out on the answer choices to be E, none of the above, so I have a feeling very, very few people actually got that one on the test. But let me just kind of recap what I did to derive these two formulas, because once you kind of know how to derive these formulas, then the actual work, you know, I mean, becomes very light, you know, just a little algebra, but getting to those formulas was a little difficult. So let me just kind of recap here. I had addition on my numerator to start with. So I added my two angle addition and angle subtraction formulas for sine. And I used sine because I had sine and sine here on my numerator. And now I got that. I got here. And now on my denominator, I had subtraction. So I subtracted my two angle addition and angle subtraction formulas for cosine because I was using cosines here. And now I let the different inputs, I have a plus b as one input and a minus b for another input for my sine and cosine formulas, right? Those are my angles, a plus b and a minus b. And I didn't really like those. I wanted them to just be one angle, one input, because that's how it is in the original problem. Here it's just one input, 12x. It's not like sine of 10x plus 2x, it's just 12x. So I wanted that to be similar. I wanted to generate a formula that was going to help me with this problem. So that's why I let a plus b be c, the sum of those angles be another angle, and the difference of those angles be another angle, which I'll call d. And then just like how I did here, I'm going to add and subtract these formulas, a plus b equals c and a minus b equals d. I'm going to add and subtract those two formulas to get a and b in terms of c and d. And the reason why I need to do that is because here I have a and I have b as my inputs. And if I'm changing those inputs to be in terms of c and d, then I need to find a and b in terms of c and d. And now I plugged what I found over here into my formulas to get this, and then just plugged it into my formula, did some algebra to get this. So I believe that is it. If you have any questions next practice, if you're watching this far, I would love to answer them, because it is kind of a cool derivation. Anyway, I believe that is it. So we're done.